CLion, a cross-platform IDE for C and C++. Download now.
Welcome, everyone. Thank you for being here. My name is Mateusz Pusz, and I'm the principal software engineer at EPAM Systems. I'm also an independent trainer and a consultant. Today, we are going to talk about making good friends in C++. So the talk is the art of C++ friendship. I will start with a trivial question, because I assume that most of you actually will answer yes to it, right? Did you use friend keyword at least once in your project? Think about it for a moment. And if the answer is yes, and I assume probably it is yes, then we are going to talk about this subject for an hour to find out how you can make good friends in C++ and which friendships are actually not welcomed in our programming language. So, in the art of C++ friendship, we have to make sure how we actually apply the friend keyword. Friend is a powerful tool, but like art, it requires skill, understanding, and careful application. We have to avoid overuse, use it judiciously, and appreciate its nuances. Let's start with simple code, like this one, right? This is a simple class called myInt with some value, a constructor, and we want to print it, right? We want to print it with IOStreams. And as you probably are already aware, this code does not compile. This code does not compile because a customization point is missing, right? There is no stream inserting operator, so the left shift operator, that will provide us the streaming capability for our type. So what are customization points, right? Customization points are the typically functions that provide custom behavior for a specific user's type. In this case, the streaming operator, also left shift operator, provides us the possibility to insert our text representation of our type into the output stream. And the same as most other frameworks, this feature depends on the so-called argument-dependent name lookup in the C++ language to find functions that customize behavior for a specific user's type. I don't have time, and I will not talk much about argument-dependent name lookup. I talked about this last time at cppcon. You can find my talk here called Name Lookup and Overload Resolution. But basically, argument-dependent name lookup is the feature in C++ language that allows us to find overloads of specific customization point functions in the namespaces, among others, in the namespaces of the function arguments. All right, so if you have an argument passed to a function and this argument is provided in some specific namespace, this namespace is also searched for the specific overload to be added during name lookup to the overload set that is passed then to overload resolution process to find the best match. So we provide this streaming operator, right? Streaming operator that just takes the value and prints it. What do you think? Does this code compile or not? If I will create my int, pass it to cout, it actually compiles, right? It compiles because I use struct here, not class. It's maybe a bit tricky from my side here, but with struct, we have public access. Even if you don't print it here, this is public access to value. Of course, if we change it to class, we get a compile time error. Compile time error stating that value is private within this context, and you cannot access private values from outside of the streaming operator. And the streaming operator specifically cannot be implemented easily or cannot be implemented at all as a member of the class because it requires to put ostream as the first argument, not our type here as the first argument, right? So if you try to put it as a member, then the implicit this parameter of type myInt will be passed as the first parameter, so it will not match the correct signature of streaming operator and it will not work. That's why it has to be non-member function. But talking about classes and structs, right? C++ offers a rich set of access specifiers to control the visibility of class members. We have public members that are accessible to everyone. We have protected members that are accessible only from the current class and its children. And also private members that are accessible only from the current class. And depending if you will use class or struct keyword, you have different defaults for the class member access. Right? Class has private access to members and private inheritance by default. So in case you want to have public inheritance, you have to type public, and members are private by default. So you don't have to type private in the beginning of the class. And then typically you have to type public to provide public interface. With struct you have public access to members. So basically the members are always public. So all of the interface is public here. And typically with struct, private would be easier to put in the end, in the separate section, to put the members private. They should be private actually in a struct. And the inheritance is public by default, so you don't have to type public in a struct. Right? So struct is not only about members, the access patterns for struct is not only about members, but also about the inheritance. It's public in both cases. All right. So in case we have a problem because we have a class and a private member, how we can solve our streaming operator? Of course, we can add the value getter. Add the value getter and then use the value getter in our streaming overload. This will work, of course, but in many cases, the streaming operator is not, the getter for streaming operator and other places is not the right solution. In many cases, adding getters will break the encapsulation of your class by surfacing the implementation details, which means that you will not be able to refactor your class. You will not be able to change its internal details without breaking the interfaces provided to the users, because if you decide to expose different type or maybe split some type to two different parts, you will not be able to do it because you have public interface that you provided that provides all of the implementation to getters, right? Imagine a string that will return you a capacity, pointer, and the size as the getters. Size has sense, right? Maybe pointer for data also have sense, but exposing all of the other stuff may be too much, right? As a getter. It depends on how you want to model your class. So when done incorrectly, getters can become a safety issue, or at least allow the users to break class invariants, because also I've noticed many getters that actually are providing too much control to the users. Like for example, if you want to return something that's big, some people just return a reference, but they forget to put const, right? And you return the reference to a member, then you give the indirect access to the member through this reference to your class, right? So getters may be also a safety issue. So let's assume that we don't want to use getters and we want to use values. We can try other operators. For example, binary operators. Binary operators provides, for example, operator plus between left-hand side and right-hand side. In this case, I implemented as the private member, as the member, public member of the class, and I adding value of our class with the other value. When I try to implement this and use it then in our myInt, it turns out that only one of those cases compiles. Number one compiles, but number two does not compile, because in such cases, the conversion will not happen, right? The conversion from one, so int, to myInt happens thanks to this conversion operator, of conversion constructor, sorry. Conversion constructor is not an explicit constructor, so it converts from value to our myInt object, right? So we can convert this from 42 to myInt. We can pass myInt and integer, and then this integer will convert here to myInt, and then those objects will be added together. If I do it in the other direction, it doesn't work, because integer does not have operator plus with myInt. And that's why it doesn't work. So this is common for binary operators. Binary operators should typically be overloaded as non-member functions, which allows the implicit conversions, if any, because class may not have any implicit conversions, for both of the arguments, not only for one. right? So let's try again. We are adding the binary operator as a non-member function. So this time we're providing explicitly 2 arguments. And we are doing the same, but this time still with getters because we don't have friends yet. And this works. This works, both cases print 43. Of course, you may say that I could also implement this with additional operator if I add this operator to my class, so plus equals, right? Compound assignment operator. Then I could use it only, I could implement this operator only with the public interface of the class. And this is true. I'm not saying it's not, this is slideware, but there are cases where you will need to implement binary operator that is not exposing the, or not possible to benefit from the class members directly. I mean public class members, right? So let's move on. Why does friend exist in the C++ language? As we said, access control is a key principle in C++. However, some non-member functions need access to class private members. We don't want to expose them through getters in many cases. And many of them can't also be implemented as member functions, right? We've seen just 2 examples, right? Streaming operator was the first one. The compound operators like plus, minus, equality compound operator, right? All of those are binary operators, and then they should be provided outside of the class. So we want to introduce our friend keyword, right? With friend keyword, we are providing declaration saying that those functions are friends of our type. With this, we can use members of our class directly in the non-member function. In the function outside of our class, it has still access to the private member value here. And when I use it in both orders here, it works and prints 43. So what is a friend? A friend is a keyword that grants a function or a class access to private protected members of another class. Notice private protected part here, right? We get access to both parts. So basically we can see everything from this class. Public, private, protected, everything is visible. So it's a really strong coupling. It's traditionally used when external functions or classes need special access to our members. Maybe you've seen both cases of this code before. This is exactly the same code. The difference is that those 2 of operators are implemented here as, or declared here as public friends, and here declared as private friends. What is the difference between those 2 approaches? It turns out that there is no difference. It doesn't matter if you declare a friend a public or a private section. Those 2 have exactly the same meaning, the same behavior. Both of them work the same. It's up to you to decide if you want to declare friends in private or public part of your class. So access specifiers have no effect on the meaning of the friend declarations. You can put them in private or public with no difference. And who can be a friend of our class? We may provide functions as friends. So those may be non-member functions or member functions of another class. We can provide other classes as our friends. Or we can provide templates, generators, right, as friends as well. And for templates, we can also provide non-member function templates, member function templates, and class templates, of course. Let's see some examples of those. This is another example where we have friend non-member function. We have class bank account that has some balance, and we have friend function transfer funds that takes 2 accounts from and to, and the amount of money to be transferred from one account to another. We have explicit constructor that sets the balance, and we have the getter for balance. But notice that this getter returns us a copy. It allows us to query what is the balance of our bank account, but does not allow us to change it through this interface, right? And transfer funds has to change it at some point, right? What it first does, it checks if the balance is big enough to actually support transfer funds, right? If not, return false. Otherwise, we decrement balance by the amount from account, and then to account we add the amount and return true. Simple, right? In order to have the right access to our member, we have to provide this transfer funds as a friend of our bank account in order to be able to modify this from external function. And actually, this function, again, should not be implemented as member function because it will not have sense to write this code in a way that I will write from dot transfer to. It will just not look right, right? This function looks better, at least in my opinion. This is how you can make a non-member function a friend. We may also try to show how friend-member functions can work. Let's imagine that we want to implement something more advanced or maybe easier to test. In this case, we want to implement some transaction. A class transaction that basically encapsulates the transaction by itself. It is virtual, so polymorphic usage of this class will be in our product. By default, it's non-movable, as all of the polymorphic classes, base classes should be by default. And we basically split our transaction to steps. We check balance, this is one virtual function, and then transfer as a second case, in case check balance returns true. And we return true false to the user, depending on the check balance return value. All right. So we have this simple virtual class, polymorphic class, and then we add bank account, the same as previously, and we just say that only transaction transfer member function is our friend. The question is, can it be just in the FAQ? I see question and answers. I see that can it be just a static method? It could be static method. I mean, then you should write something like transaction : transfer every time you want to call it. I mean, sorry, bank account : transfer, right? And this would be probably not the best idea to write it this way. But this is just an API sense how you want to call it. In some cases, static functions have sense. Static functions, yes, correctly have access to members, also to private members, so you can implement this easily as a static function. But in some cases, API does not look right through static functions, right? All right. Next, if I try to call this or compile this code, actually it doesn't compile. When I get a compile time error, I immediately know what's wrong. It says that the transfer is private within the context, right? This transfer is private part of our polymorphic structure here, polymorphic hierarchy. Just run is a public interface. So I cannot refer to transfer here as a friend. In order to be able to refer to this transfer, I have actually to declare this also as a friend, bank account as a friend of our transaction, so I can actually access the private transfer from bank account as a friend, and then transaction has to be transfer has to be a friend of ours in order to be able to access the balance inside, right? And when I try to compile this, again it doesn't work. Because it complains that the bank account here is not known, does not name a type. So what we can find out is that friend class declaration does not declare a class. It just declares a friend, but not a class in our class. So we still have to provide explicit class declaration here. So I have to declare the class bank account, then I can say that bank account is our friend. So bank account can say transaction transfer is our friend, and then transfer can actually use balance inside in order to implement this. If I make a transfer funds a template, so for example, I have some custom representation for the amount. It can be int, short, long int, right? Then basically nothing changes here. I just want to show you how to declare such function template as a friend, right? You just provide the signature of this friend function saying that for every rep, this is our friend. In case you make a bank account also a class template that basically balance is also using rep, you may say that only transfer funds for the same rep is our friend and no other. Also, you can simplify this by just removing the rep from here, because typically inside of the class, you don't have to type rep everywhere, right? I don't type here angle brackets rep here, because it means by default that I'm referring to this bank account of rep. So also here, rep will be the default in this case. All right. In case of friend class templates, you may say that we have two class templates, A and B. I may say that any specialization of B can act as A. I may also say that B of T can act as A of T only. So they have to have the same T in both cases. Or I may say that B of int can act as A of T, and this is our friend. Everything depends how your classes interact with each other, how they depend on each other, what actually the template parameter mean, because the name T is often overused, right? It doesn't have to mean exactly the same thing in two different classes. We often hear that friendship breaks encapsulation. Let's first talk about what encapsulation is. My definition of encapsulation is that it's the art of bundling data and behavior associated with a single responsibility behind a clean interface, concealing implementation details, securing class invariants, and enabling effortless refactoring. And this last thing is really important, right? We encapsulate stuff so we can refactor implementation details without much hassle, without having to change user's code, the client's code, right? So all of that is inside is an implementation detail. Everything that depends on this implementation detail breaks encapsulation. So okay, you may say, so yes, friends then break the encapsulation. But there is a perfect article by Scott Myers called How Non-Member Functions Improve Encapsulation. Scott Myers wrote, if you are writing a function that can be implemented as either a member or as a non-friend non-member, you should prefer to implement this as a non-member function. That decision increases the class encapsulation. When you think encapsulation, you should think non-member functions. It might be counterintuitive to many of you, right? We often say that we are encapsulating stuff, but putting members to a class and everything to a class, all of the interface that works on those members. But each of the member functions increase coupling and decrease encapsulation actually. One of the perfect examples of that is our std string. I know that you cannot read that, but this is all of the interface of std string taken from the standard. std string class template has 140 member functions plus 25 special member functions. That's insane. That's a lot to actually maintain. A lot to change. If I decide to refactor my internals in a string, I have to possibly refactor 140 member functions because all of them possibly depend on our private functions, private members inside. That's not how encapsulation should be treated and basically reasoned, right? This is also a problem because, for example, right now, I want to propose in-place string to the standard for C++29, and possibly I will have to specify all of those nearly 200 member functions for another type just to be compatible with std string. Most of those would be much better as non-member functions or non-member function templates, and then specification of another string-like type would be much easier. And refactoring of the internals of such classes will be much easier as well. So member functions do break encapsulation if you are doing this wrong. So do friends actually violate encapsulation or not? A friend function in the class declaration doesn't violate encapsulation any more than the public member function violates encapsulation. Both have exactly the same authority with respect to accessing the class non-public parts. This is the quote from the C++ FAQ, right? So if you think about this, there's no difference between non-member function being a friend or a member function in a class. They have exactly the same encapsulation effect. The only problem may be that difference may be remote in the files, maybe harder to find, for example, during maintenance or refactoring, but they have exactly the same, basically the same effect on the code we write, right? They have exactly the same access, break the encapsulation in exactly the same way. So if you think that adding members is for free, but adding friends is not, probably we could rethink that, right? A few rules of friends in C++. Friendship in C++ is not inherited. If I have a class X and I say that base is my friend, base may access my value, but derived from base have no access to my value. Right? If I want to compile this code, I will get information that X value is private within this context, so no access cannot access this one. Tight coupling of classes is fine as long as those are created and maintained together. For classes that are created by other users, other developers, it would cause a maintenance nightmare and prevent any changes to the original type. Right? So it is fine to actually have two classes being friends to each other, because actually they actually form one bigger class. But for example, each of the classes may have different lifetime. And that's why you have to split them to different types, so the lifetime can be different, but they serve the same functionality, for example. The same responsibility, right? Friendship is not transitive. If class X has a friend Y, and Y has a friend Z, then Z can access Y, but cannot access X. And of course, Y can access X, right? So friends of your friends are not my friends, not necessarily. And friendship is not mutual. The fact that X calls Y a friend doesn't mean that Y treat X as a friend, right? So Y can access X, but X cannot access Y. So to summarize, rules of friendship in C++. Just because I grant you friendship access to me doesn't automatically grant your kids access to me, your friends access to me, and grant me access to you. Again, quote from C++ FAQ. All right, so those are the rules of friendship, encapsulation. Let's now talk about some stuff that friends should not be used for. First and foremost, friend is not a unit testing solution. As a consultant, I've seen so many code bases where actually production project having some framework provide implementation details, more implementation details as private functions, and then define something like this: friend class framework test. And then framework test was basically testing the implementation details of the framework. This is so wrong. This breaks encapsulation. It increases coupling between tests and implementation. if you will refactor framework, you have to refactor all of the tests. And implementation should be easy to change, right? This is software. It should be easy to change. It should be soft. You should be able to refactor stuff, assuming that you are not accounting on ABI, which is a burden in our environment. But ABI aside, you should be always able to change your internals without affecting the customers. And actually, doing this approach encourages bad design. It leads to testing internal details instead of the behavior of your class. What you can do instead? You can apply the single responsibility principle, SRP, right? Decompose the monster monolith you have in your production code into smaller testable classes, where each has its own responsibility and each is tested separately. I've seen so many cases where actually there was a monster that was doing 10 different responsibilities, had hundreds of member functions, and then plenty of those things were private. If you decompose this to smaller pieces and then put them as members, then each piece separately will have its own interface, its own responsibility, and could be tested separately. And actually, it's much cleaner design, much less tests needed to be run, because you just test each thing separately and maybe do some integration tests, rather than trying to find out all of the combinations of all of the possibilities in your monolith to make it work and verify if it's correct or not. Of course, you can use dependency injection to improve testability, mock interfaces instead of exposing private details. And yes, you can use getters, but please use them only when necessary, right? Do not expose your implementation details to the users unless really needed, right? Every getter exposes some implementation detail, and if you don't have to use them for the logic of your program, other than testing, don't add the getters only for this reason. And please, don't try this at home, right? Don't define private public. I've seen those as well. One friend is not needed. When I have a class template storage that has some internal buffer, I have iterator that wants to iterate over this buffer, over the storage, and I return this through begin, right? Then the storage iterator, when it's defined, it gets the storage as the argument, keeps it here, and then in operator ++, I can access all of the private members of the nesting class with that friend keyword. In this case, you don't need friend. You are already having access to the private members by default. So nested classes have access to the outer classes scope as needed. Some time ago, I approached a really nice article by Arne Mertz, and he stated that friendship is the strongest coupling we can express in C++, even stronger than inheritance, which is true. So you'd better be careful and avoid it if possible. And I agree with this as well. I'm not saying that friend is good. I'm just trying to explain what is friend and how to use it. I'm not saying that you should use it everywhere. Friendship often breaks encapsulation, like members functions do as well. Don't do this too much. Often seen as an indicator of poor design. It's mostly caused by the lack of friendship granularity. Whenever we make a class a friend, we give it unrestricted access to all our members. It also threatens class invariance. Friends can mess with our internals as it pleases. Let's see this example. We have some secure session, and we have some factory for those sessions. Factory is needed because we want to make our constructor no except, because there are code bases where exceptions are not welcomed and there's no good way to return an error from the constructor, right? That's why I created this as a no except constructor, and I have to do verification of the input before the constructor is being called. And I have some internals besides this private constructor, because this constructor is private. I also have some generate random token for the secure session, and they have some handle as the private member, and the secret token generated by this function as a private member. Factory should have access to this constructor, probably should not be able to generate tokens, and for sure should not be able to replace what we have here. But it has, by default with this design, right? If I declare session factory a friend, it has access to all of the members, private members, and protected as well, of course, if there are any. So I have make secure session, and I check if it valid this URL, then create the session. Otherwise, I'm returning null-opt, because notice it returns the optional of secure session, right? That's why actually I have this no except here, because I do all of the validation outside. And then when everything is fine, in the end, I'm calling secure session. That will never throw because I know that URL is already validated. Otherwise, null-opt as the, let's say, error, well, although optional is not an error, right? And this class also may do a hack on our session. It can replace the secret token with mu because it has access to it. What we can do with that? We can actually replace our session with constructor key. We can create a constructor key here that will be friend of our session factory. We'll have private constructor, and we'll have private copy constructor. And we can add this constructor key as the last argument to our constructor here. And this constructor right now is public. The only thing that has changed on the factory is just adding those curly braces here. Those curly braces that create the default instance of this constructor key. And only session factory is allowed to create the instance of this constructor key. So it means that only session factory can access this constructor. And it doesn't have access to any private members because it's not friend anymore of a secure session. Another possibility, before C+20, you would need to actually provide the proper definition of this constructor key, not the default, because before C+20, this will be treated as aggregate, and you could call aggregate initialization in order to create the construction key. So before 20, you have to put curly braces here for the default constructor. Also, this one has to be private, because otherwise, a hack like this one, so taking a pointer and then reversing a pointer, could make it work for us, even though this is undefined behavior, but supported by all of the compilers. Another possibility is to use another idiom called attorney client idiom. With this, we create a factory attorney that basically says that session factory is our friend, and we just expose a make function that constructs our class, and then this one has only access to the make function and to nothing else. So basically, this factory client idiom is that the attorney is a proxy type that basically allows us to expose only a part of the interface of our class to customers, not the rest. All right, let's recap. I started with this slide saying that why do we have friends, right? Let's try to build on top of this example a bit more. Let's make my int a template. To make it a template, I just add the template parameter here, and I have to do all of the operators and all of the class implementation having templates. Notice those angle brackets here that are needed here in order to say that those are templates. And I also needed to provide those declarations first, before I actually can then say those specializations actually are our friends. But it doesn't work. The code as a non-friend works, non-template, and code being a template doesn't work. What is the problem here? The problem is that templates behave differently than regular functions in the overload to solution process, and basically while calling them, right? What doesn't work right now is that those things do not convert anymore, right? We are saying that operator plus takes only my int of t and my int of t. And this is not my int of t. This is 1. This is integer. That's why operator plus is not found. Right? So how does it work? If you have a function template like this one, then t is a dependent name on t. This one is a dependent name on t as well. X is not dependent. If you have dependent argument, then you only do parameter argument adjustments, like dkt-like, right? So all of the cons may be removed, all the differences may be removed, arrays are converted to pointer to arrays, functions are converted to pointer to functions, and so on. We also consider some alternatives. For example, more civilly qualified pointers or references, or also base classes are considered in this case. But we don't do any additional conversions for such parameters. For not dependent parameters, we do trivial conversions, we do promotions, standard conversions, or user-defined conversions, so calling non-explicit constructors and conversion operators of the class. As conversions are not considered, in this case we have to provide more overloads. So I'm providing the operator plus for t and for t here, right? On both sides of my int. Declaration, specialization, and then implementation. And yes, it works. Also, I could actually reuse the public interface. I don't have to make them friends because I just create my int from t and then just use the other operator plus that is already a friend. Fine. If t is cheap to move copy, this is fine. For some cases, it might not be. For example, imagine string. You would have to always allocate string in case of const star, for example, being passed here in order to add two strings together. So this is unnecessary allocation in this case, possibly, assuming that small string optimization does not run here. But as I'm having here t and t, two different types, and I have it as a template, I have a reason to provide those representation types here. This is for ints, but it means that I want to work with other representation types as well. So I want to work it with short, with ints, and other types. If I try to make it work on various types, again, it doesn't work, and I have plenty of errors saying that, for example, my int and my short cannot be found because they do not convert again, and the parameter t and t cannot be determined as the same by the compiler. So what I have to do, I have to use t and u in my overloads, right? And I have to return common type as a result. So my int of a common type, I know the simplification for some cases, but let's assume that's enough here, is a result of adding my int of t, my int of u will be my int of common type. And I'm doing the same logic. And again, it works for the rest of the things. Now I want to add additional class called 0. 0 is just my int with value 0. This is conversion operator. And if I do I plus 0, I expect still 42. 0 plus I, still 42. This was for non-template case. It just worked. For template case, again, it doesn't compile. Right? Because, again, it doesn't convert properly. We could make it work with additional overloads, but I assume that most developers at this point would just give up. You may be wondering where I'm going with that because I didn't talk about friends too much for a moment, right? But I promise I have a point here. This was how I started my lecture. I said that if we not provide any customization points, we don't provide string operator, this provides error message, and I provided this error message to you. And I lied. This was not entire error message. This is not that nice as here. What is the actual error message? A long error message showing you all of the overloads from the std namespace for all of the string operators for all of the types, and there's 128 lines more here. And I'm lucky here because I'm using clang 19, because in JC14 the error log is even longer, and there's even more 300 lines in the error message in the end, for such a simple code example as you've seen. Inevitable side effect of popular customization engines, for example, string insertion, is a large number of function overloads customizing specific behavior. We always and often complain about templates being so slow to compile. But after many measurements in many production projects, it turned out that actually name lookup and overload resolution typically are the most expensive things to do at compile time, not just templates. Let's try to do it on the other operator, not only string operator, but operator plus. Let's add some myFloat that doesn't have operator plus, so it's broken. And I'm just calling this fact. And when I'm calling 1 plus myFloat, it proposes me operator plus on my ints. It doesn't have sense to actually propose those, to consider those at all, because my ints are not my floats. But this is what compiler does. Compiler looks for all of the names operator plus, no matter what are the arguments, and tries to use them in some specific case. That's why those error messages are so long. That's why the compilation takes so long as well. We want to improve that. You probably face slow compilation due to template overloads a lot, right? What we can do to improve that is to refactor our myInt. If we refactor our myInt and put all of the definitions inside of our myInt class template, so do it like this. It fits on one screen right now. We don't need any declarations. We don't need any definitions outside. Also, it is easier to maintain. I talk about encapsulation, right? Right now, the cost of this function is the same as the cost of any other member function because it's defined in the same place as the class. So it's much easier to maintain as well. And with this, it turns out that automatically all of this works, including 0. No need to declare anything. Everything is defined inside of the class template. We don't need any function templates for our declarations. We don't need any friend declarations. Conversions from 0 work thanks to non-template overload, because there is, I did actually mention this explicitly, where I have it. But here is version with no type T parameters. This is just a non-template overload. Both of them are non-dependent names. So it means that conversions happen for them properly. And this is more powerful than just passing a template parameter. The remaining arithmetic with other types works thanks to additional overloads as well. If I try this again for my broken float, I just get the information that this doesn't compile. It doesn't propose any other overloads. The other overloads for my int are hidden right now. If I add one more function called ABS for my int, in the case where I had external friends and internal friends, this is the cost of the external friends, this is cost of the internal friends. The right column is much simpler to maintain, much simpler to write, right? And both of them work nicely. However, there is a difference. If I try to call ABS with qualified lookup, for example, add the namespace name in front of it, the left column will work, but the right one will not work. The right one, the ABS here, is not a member of the outer scope. It's not the member of the outer namespace. It's just associated with our class template. It's not a member of it, but it's also not a member of any other namespace. It's just a hidden friend function that can be called only through argument-dependent name lookup. And that's why actually we have this name, hidden friends, because they cannot be accessed explicitly from an external scope. And hidden friend functions are the friend functions declared and defined inside of a class, and taking this class as an argument. So something like this. Such functions can be found only through argument-dependent name lookup. So this makes it perfect candidates for all of the customization points, because we said that all of the customization points, or most of them, work thanks to actually argument-dependent name lookup, and those can be found only for argument-dependent name lookup, so this is a perfect match. Right? So there's a recommendation stating that you should always use hidden friends for customization points, even if you don't require private access to the members of the class. Even if you can work it with just public interfaces, still make it hidden friends to possibly save typing because declaration is simpler, but also to speed up the compile times you have, right? And provide clearer error messages to the user when something doesn't compile. However, there are some issues with typical implementations of hidden friends. In case you don't think about or don't add or forget about adding such an operator that is non-template one, but you have the other one saying I have my int and I want to compare with another int, and you think that's enough, it is not. Because if I have this code, I have my int and my short, I do 0 plus I, it works. If I do I plus 0, it doesn't work. So it's basically not commutative. And that's really, really bad. Right? It's bad because this one works with conversions from overload resolution. This one works only for template argument deduction. That's why this one works, the other one won't. If you replace those two, the other one will work and the first one not. So you may think that maybe adding another one that will have replaced parameters will be a solution. And yes, it will solve the problem of 0, but then you will not be able to add my int and my short because you have ambiguous overload, because those two will be equivalent in this case. You can solve it with using template parameter for both cases. So you can use the parameter for the left-hand side and right-hand side. But in order to make it work, you have to do some tricks. Instead of saying this is my int, use a concept saying this is the same type as my int. With this, you have no conversions at all, which may be good in your case, right? Because it's what we want to achieve. We want to achieve basically the same behavior for both cases. And having this as a template basically is as good for both cases. Nearly, because if you want to inherit from my int, then the right-hand side will work better than the left-hand side. So maybe you want to actually use the write from my int, which will also work in this case. Another possibility to solve it, maybe in a nicer way, is to use hidden friend injection idiom. With this, I have class template my int that basically has only parameter t, and all of the binary operators are put in my public base class. And this public base class here, what it does, it provides all of the operator plus overloads for binary operators. And with this, all of them are templates. Left-hand side and right-hand side are exactly the same syntax, so they have exactly the same behavior, no matter which one is left-hand side, which one is right-hand side. And this will work. It will not work for my int base, because if you will try to work with my int base, it will not work because those are not my int bases. Well, they are because they are derived. Okay, so it will work for my int base. But it works for my int as well, because those are my ints. This idiom allows you to basically make all of the operators commutative and disables implicit conversions, which possibly makes your interfaces asymmetric. And you're doing this by putting all of the hidden friends as function templates in a base class. Also, it enables hidden friends usage for a family of otherwise unrelated types that satisfy the same concept, for example, while preserving the most derived class type for a hidden friend function's logic. Let's see what I mean by this. In my library, a physical units library called MP units, I have basically plenty of units, right? Those units are tag types, and you can do operations on those tag types. I called actually those symbolic constants, not tag types. So symbolic constant unit is a symbolic constant that is derived from unit interface. Unit interface provides all of those operators for 2 units. Both of them are template parameters. And then I'm deriving, for example, name unit from the unit interface, direct unit from the unit interface. And then I create meter or second by deriving from named unit here and here. And then I can check that if I divide meter per second, I will get a result of direct unit meter per second using the types I passed here. So the implementation of this operator takes the most direct types. So this will be meter, this will be second, and constructs proper type here, even though it's in the base class hidden inside of the implementation of named unit and then of meter. Still, from the base, I can work on the outer types and provide the correct result, and those are still treated as hidden friends of those. So the unit interface is provided only for units. For example, quantity interface provided only for quantities, and etc. Right? And you will not see errors from one in another. They will not collide, and the error messages will be nicer, shorter, and the compile times will be faster. So to summarize, friend grants a function or class access to all private and protected members of another class for data and functions as well, right? Introduces strong coupling between two otherwise independent entities. Friendship in C++ is not mutual, transitive, inherited. Use friends when compilation performance and compilation errors clarity is a concern, which typically is the case. So use them especially for operator overloading and other customization points, because there will be plenty of functions with those names in your code base. Use friend when external functions need special access and can't or shouldn't be implemented as member functions. Use friends when two classes are tightly coupled but can't be merged together, for example, because they have different lifetime. Avoid friendship for unit testing. When encapsulation is critical, consider passkey or attorney client idioms to limit the scope of the access. When there are better alternatives, like dependency injection, singlest possibility principle, and so on. To summarize, friend is a powerful tool, as you've seen. But like art, it requires skill, understanding, and careful application to make it right. Avoid overuse, use it judiciously, and appreciate its nuances. And that's it. Thank you very much for joining. I hope that you liked it. We don't have much time to actually answer your questions right now because we are out of time, but I invite you to gather town and we'll answer all of the questions there. So see you there in a minute. Thank you very much.